continuing to work on graphing linear inequalities. And so we should know by now that if we've got a greater than or a less than, and we graph the inequality and we got the proper region shaded, whether we do that using a test point or we allow our calculator to do the work for us, that if it's a less than or greater than, it's going to have a dashed boundary. And also then, if it is a less than or less than or equal to, or a greater than or equal to, we're going to have a solid boundary for our region. And so now we got a little word problem here that we're going to do and use to illustrate a solid boundary, which we're going to do on the calculator once we get to that point. Manuel has $15 to spend at the county fair. The fair costs $5 for admission, 75 cents for each ride ticket, and 25 cents for each game ticket. Not very expensive. Write an inequality and draw a graph that represents the number of ride, R using R, and game tickets using G as the variable that Manuel can buy. Well, let's see. Let's start off. Well, he's got $15 to spend. Well, if I'm doing this as an inequality, then whatever I set up on the left side, he's got to do with less than or equal to $15. So there's his $15. Costs $5 to get in, so he's got to spend $5 just to get into place. And then it's 75 cents for each ride ticket. Well, so we can say plus 0.75, and we're going to use R for ride tickets. And he's got 25 cents for each game ticket, so then we can set up 0.25 G. Well, there's actually our inequality. But if I want to graph this, I've got to solve for one of the variables. So let's solve for the variable G. So I'm going to rewrite this. So first thing I want to do is subtract 5 from both sides. So now I've got 0.75 R plus 0.25 G is now less than or equal to, let's see, 15 minus 5 is 10. And then let's subtract the 75R from both sides. So we're going to isolate the game ticket. And we could do it the opposite way, but this one will work pretty well. So now I've got 0.25 G, game tickets, is less than negative 0.75 R plus 10. Okay, so we're multiplying the game tickets by 0.25, and so if we're going to isolate G, which we're going to use as our Y less than or equal to, when we go to the calculator, that means I'm going to have to divide this by 0.25. You know, 0.25 is really 1/4, which means I'm going to multiply everything by 4. Or you could divide it by 0.25, you'll get the same answer. And then when I do, I'm going to have G is less than or equal to negative 3R, that's 4 times 0.75. 2 times 0.75 is $1.50. 4 times is going to be $3. And 4 times 10 is going to be plus 40. All right, we're going to jump to the calculator. We're going to graph this, and hopefully we're going to have a solid boundary. All right, well, here we are, and we're going to graph this. I'm going to substitute the G for Y and the R for X, and we're going to graph our inequality. And let's see, first thing I probably want to do is clear what I've got. And then I want to set this inequality up differently, because I don't want a greater than, I want a, what did I say, less than or equal to, yeah. All right, so we'll move our little cursor down. I'm using the inequality app, as you can see. There's greater than or equal to, equal, less than or equal to. Okay. So we're going to select OK. And now we're going to graph our inequality, which was -3. And remember, we're going to substitute x for r plus 40. Now, I got a feeling when I go over here to this graph, in fact, I'm going to do it this way. I'm going to, because I got that plus 40, I know this thing's going to head off the scale. So I'm going to hit zoom, and I think I want to choose option 0, which is probably fit. Yes, option 0, zoom, fit. All right, well, there we go. We see that we've got an inequality written. I've got a solid line, not a dashed line. If I didn't have the inequality app, then I would just need to know, because it's less than or equal to, that it is a solid line. But thankfully, if I've got the inequality app, it does the work for me. Shazam.